Welcome to DevOps Days Minneapolis. Please take your seats. Our program will begin in 15 minutes. DevOps Days Minneapolis participants, please take your seats. Our program will begin in 5 minutes. Minneapolis participants, please take your seats. Our program is about to begin.
Until noon. We are closing the desk at noon, or talk to anyone with a staff badge. I want to have you make some noise again for our sponsors. The sponsors paid for everything, so let's thank them. Yes. And our sponsors also, a number of you may have entered some raffles, and you are all definitely going to win. However, you must be present to win. So the raffles are all happening right here at 3 p.m. So if you would like to win all of those wonderful items, and if you're thinking to yourself, wait a minute, winning things, make sure you spin by, talk to all the sponsors, enter your names, and you can win stuff. All right. Again, we're using hashtag devopsdays. I saw people were being creative and making up their own hashtags, and I assume that for anyone using something, fancy like TweetDeck, you can be searching on all those hashtags. I recommend just using hashtag devopsdays if you would like to tweet about this content so that people actually find it. We, again, do have a Slack. I can assure you I am absolutely not active on there because not holding phone and on screen. And on stage. But there will be people from this community who have invited themselves to that Slack, and you can talk to each other during the conference and beyond. We do have monthly meetups. I was just having a wonderful conversation with Paul Dokas. Where are you, Paul? A security professional who I worked with many years ago, was full of ideas from open space yesterday and wants to give a talk at our meetup coming up. So we'll probably have some security-related content in August. And again, once again, remember, we had a lot of stuff that was hopefully thought-provoking and making you think about your role as technologists in the world. And one of the ways we can affect the world is voting. So if you are not registered, if you moved, if you're not sure, you should probably check that out because you probably want your voice to be heard. I'm going to guess, based on all the active discussions I saw in open space, you want your voices heard. Reminder again about our code of conduct. And I think it's easy to say, be excellent to one another, signed Bill and Ted, but like what we actually are trying to do is create a space that everyone can be heard, everyone can participate. And if we're not mindful and careful about that, we can end up feeling like tech is just a completely homogenous blend of people that are the exact people who are exactly like you. And as we've all probably noticed when trying to create and use technology, not everyone's use case is the same, not everyone's experiences are the same. So please be mindful of that. Take a look at the code of conduct on our website. Today's schedule, our opening welcome right now, hopefully brief. It is counting down for me, so excellent. We have our first speaker, then we'll hear from some more of our sponsors. We have our second speaker, we'll have a short break. We'll have our third speaker. These are all wonderful speakers, of course. We'll have, hear a little bit more from some of our sponsors, and we'll have our last speaker. And if you're thinking, oh, excellent, it's Friday, I get to leave, possibly after eating some free lunch, and go to the lake. I mean, maybe. It is a bajillion degrees out there, though, and we have air conditioning. So what I would recommend doing after lunch is either you have choices behind door number one is if you got your workshop on yesterday, or if you didn't, but you kind of wish you had, we're going to have some of those topics that everyone seems interested in. Actually knowing what's happening in your systems, or hey, things are going wrong, how do you respond? So we have interactive workshops. Again, the workshop seating was overflowing yesterday, so if you're interested in the workshops, just be aware they are first come, first served. We're not going to let you take your lunch and eat in there to reserve a spot. So eat your lunch, socialize, and then first come, first served at the workshops. Your other choice, of course, is open space. So all of the things you've been thinking about for the last day, this is going to be your last chance this year, unless you are one of the people whose names is on here. This is your last chance this year to stand up here, hold a mic, and tell people what you want to discuss. So start thinking about your open space proposals. And then, of course, it's very important if you would like to win all the things that you're definitely going to win. We have our break and everything this afternoon is 15 minutes earlier than it was yesterday. So break starts at 2:45, and the raffle is exactly at 3 o'clock. And again, must be present to win. And then we are going to be closing the day here at 4:45. And at that point, you go forth, do DevOps, be excellent, and all of that good stuff. So thank you again so much for coming and participating in DevOps Days Minneapolis this year. And I want to welcome to the stage come on up, Aditya. Our first speaker today. I think I first saw him speak, I want to say it was Monotorama in 2014, 2015? I'm not sure. But Monotorama a couple years ago. And what struck me is that we all say we want to know what's going on in our systems. And that's great, but how? So that is what we're going to hear. Thank you so much. Give it up for Aditya.
Thank you, Bridget. Thank you all for coming. I know the first slot of the second day can sometimes be a little bit tough for a conference, so I'm excited to see how many people are here and interested in hearing about how unified observability pipelines work. So as Bridget mentioned, my name is Aditya, and I work on the observability team at Stripe, primarily on our open source monitoring and observability tools, which you'll see in a moment. At Stripe, we provide a simple unified API that enables businesses of all sizes to accept payments online. Today, I'm going to tell you about how we've built and how we're continuing to build a unified tool for full cross-sectional visibility into all aspects of your system's code. Now, if you're a big company like Google or Twitter, you can create your own integrated tool that handles all of this for you. And Google has done that. But for the rest of us, we're probably relying on open source or third-party vendors for at least some portion of our monitoring tools. And it's hard to get fully integrated cross-sectional visibility into your code if you're using multiple tools, because there'll always be gaps in between them. Fortunately, though, there's a way that companies smaller than Google can get this level of visibility without writing their whole stack from scratch. And the secret there is all in the metrics pipeline. So I'm here today with one goal: to inspire you all to take control of your metrics pipeline. And not just any pipeline, but an intelligent, context-aware pipeline that can help you achieve the pinnacle of system observability. Some of the stuff that I'm going to talk about already exists today in our open source tool called Veneur. Veneur is our take on an intelligent metrics pipeline, but it's not the only one. And some of what I'm talking about is what we'd like it to become. And that's the exciting part. You can help us all out with that. Because we want to make intelligent metrics and observability pipelines like Veneur the gold standard for observability across our industry, and to make that gold standard accessible to companies of all sizes. So how many of you have ever been on an on-call or pager rotation? Yeah, DevOps Days probably like most of the room. Is anyone on call right now? That's like a lot more than I was hoping for. So if I like hear just, like a phone go off and suddenly like people are like darting out of the room, I'll know it's not just like, you hate my talk or something. So I'll tell a story that may be familiar to some of you. It's 3:07 in the morning, and you're happily asleep, dreaming, and suddenly your pager goes off. Now, you want to get back to sleep as soon as possible, but obviously you have to fix the problem. So you need to figure out what's actually going wrong. So what's the first thing that you do? Any ideas? Yes, how do you do that? Sorry, someone said, see if there's a real problem. The answer is yes, how do you do that? I heard someone say a dashboard, which is, yeah, probably what most people would do. You pull up a dashboard. So here you go, and you see that API success rate has dropped just below a threshold. There's a little dotted line. You may not even be able to tell. But all right, so our error rate has exceeded, our SLA, which means that there is a problem. But why are our requests failing? For all we know, maybe there's a badly written web crawler which is, generating 404s. So to investigate that, we have to pull up another dashboard. And all right, here we can filter by an arbitrary database shard and a country combination, and we see that there are some sporadic but consistent requests that are timing out. And so some requests are failing, but we don't know why they're failing, and we don't know how widespread it is. All we know that it's in the US, this particular database shard is having issues. So we could, just spot check more database and country combinations, but that gets really cumbersome. So we go to another dashboard. And this one shows us by server. All right, so now we're looking at across our entire cluster, and we see that 4 boxes or 4 pods are having issues, and the rest are fine. So this is good. Now we get a sense of just where this problem is shaped. Now graphs like this are efficient because they pre-aggregate data. We define the axes that we care about in our instrumentation using tags like country, database shard. And then that's aggregated at runtime, not at query time. So graphs like these are therefore very easy and efficient. They're quick to pull up. But we want to be able to de-anonymize our dashboard data. We want to know things like the types of requests, the users, the HTTP method. And we can't count all of those axes because the cardinality is too high. There are too many different axes for us to actually aggregate all of those at runtime. We need to do some of it later on. We can explore arbitrary dimensions in our data using our logs, but then we have to take the time and the effort to actually interact with them, because logs are not pre-aggregated. We have to figure out how we want to search and query them. So it turns out that this exact regex right there will match only requests that take 30 seconds or longer, regardless of what format they're specified in, whether that's 90S or 1M2S. It will actually match that. I double-checked it. It's hard enough coming up with that when the pressure's off, but imagine trying to do that when it's in the middle of the night and your servers are down and trying to figure out what's going on. No one really wants to do that. When you've been paged for an outage, you want to have quick and readily available access to that. And of course, our logs are always going to be slower than our pre-aggregated data because it's extracted at query time, not at runtime. So they let us look at arbitrary data, but they're always going to be slower. Fundamentally, though, they are different views on the same data. You just have to reconstruct each view independently instead of being able to go straight from one to the other. And oftentimes, you're going to just end up poking through individual log lines anyway, unfortunately. Because, how many of you have ever written log lines that look like this? No one? Yeah, no. You can admit it. It's OK. I have. I'm making it look a little silly here, but when you think about it, most uses of logs actually do follow this overall pattern, where you're basically saying, all right, I'm about to do a thing. Now I've done a thing. All right, now I'm finished doing the thing. You don't actually care about the text of the logs in this case when you think about it. About to query object, that doesn't mean anything. It's just a way of disambiguating that particular log line from all the other ones so that you know that that particular line of code was executed for that object ID compared to others. And so when you think about it in that light, you realize that you're just using logs like a runtime debugger. It's GDB, but by human. And so reading the logs to figure out the source of a bug is really just one step away from saying, you should read the source code to analyze it and figure out where the bug is. Because logs are really just developers talking to themselves. They're like, hey, I reached this part of the code. OK, I'm still here. I reached this other part of the code. All right, now I'm still here. Pay attention to me. That's really just what logs are. Like, I've gone so far as to say that you actually should never really be looking at your logs. If you ever actually need to look at your logs, that means that something is wrong. It means that there is a gap in the rest of your system's observability tools. Now, one other tool for filling in that gap is request tracing. For those of you who haven't used it, request tracing, it's a very fancy term for a fairly simple concept. If you've ever looked at a stack trace or a profile of, of your program to see which functions are calling which and how long they're spending, that's all request tracing is. The only difference is that request tracing shows you that across all servers simultaneously, if for a single request that needs to touch multiple servers before returning a response, you get all of that, and hopefully color-coded by which server they're on. So you can see here that the green, the purple, the blue, those are all different servers, but those functions are just calling each other. So OK, you've gone to another tool. So now you've looked at 5 dashboards across 3 different tools just to solve the problem, and you may not actually have gotten any closer to it, because if you're lucky, you have tracing instrumented around the code that's breaking. But you might not. And even if you do, it's still not wholly integrated with the dashboards that you were just looking at. Now, in physics, all matter is built using certain fundamental particles. We have electrons, we have protons, and we have neutrons. And everything we see, everything in the observable universe, is built using these fundamental physical particles. And in observability work, our tools are also built using certain fundamental particles as well. We have metrics, we have logs, and we have request traces. Now, the challenge with metrics, as we saw, is that there's no context. They're pre-aggregated, so they're efficient, but they lose their context. With logs, we have the opposite problem. They're not pre-aggregated, so they're not as efficient, but they do have everything. But they're hard to aggregate. And request traces, they require careful planning so that you actually know that you're instrumenting the code that you need. And that's actually not unique to traces, because that's shared with all observability tools. Because monitoring information is really only going to be useful if developers have put in the time and the effort to predict. And not just to predict, but to correctly predict which parts of the code are most likely to break, and what information is going to be needed to debug that code from a broken state. You can think of it like tests. It's relatively easy, usually, to write a test case for a bug once you've already identified the bug. But it's much harder when you're writing code the first time around to predict all of the possible failure modes, all of the edge cases, test all of those, and ship that to production the first time. If you think that you can do that, come talk to me, because, man, have I got a job for you. Metrics are like tests, but higher stakes, because you pretty much only ever care about your metrics when things are already going wrong in production. And this is why one of the main reasons why they say that the people who write a service should be the ones who are on call for the service. It's not a punitive statement, it's just a practical one. The people who write the service are the ones who have the context necessary to predict that, and then to use that information and debug it correctly at runtime. And I mean, this is a really weird philosophy when you think about it. Like, imagine if we applied that to other forms of engineering. Imagine if we built houses this way. If we built houses the way that we build software, the builders would never be able to leave your house. They would have to stay there and operate every single door and light switch for you. And if your light bulb goes off, fuses in the middle of the night, you'd have to call up the architect and he'd send someone over to go collect some data and say, yeah, it looks like your light bulb is fused. And then he'd have to get the stepladder and change it for you. It's ridiculous. We don't accept that for any other forms of engineering, so we shouldn't accept it for software engineering either. And this is what observability means. This is what observability is all about. It means designing the interface to facilitate operability of systems at runtime by anyone, not just by the people who actually wrote the code in the first place. So let's say that we're writing a really basic web app. We just need to fetch and return objects from a database. But of course, we want to observe this. It's a very important function. So we want logs, we want metrics, and we want request traces. Let's say that our database client is tracing aware, so we can actually pass it in and get that stack trace from the client as well. So how would we instrument just this very simple 3 lines of code? Well, if you want all 3, you'd end up with something like this. So what are we doing here? We first start off, we set up a trace for the stuff, then we do the stuff, then we emit a metric for the stuff, then we log the stuff, then we set data on the trace span, and then we finally return the stuff. We're tagging the metric with the axes that we want to pre-aggregate at runtime, and then we're logging the rest of the parameters, which are just too numerous to, but which we might still want access to later. Who wants to write code that looks like this? right? I hope not. This is very boring. This is so boring that I almost even didn't finish putting together this slide for this talk. That's how boring it was. So if I can just barely be bothered to put together a slide demonstrating how boring it is for a talk, there's no way that we can expect developers to go through this whole song and dance everywhere in their code anytime they do absolutely anything at all on the vague hopes that that data might be useful in debugging a production incident. At most, we can expect that they would remember to write one line for instrumentation to observe their code. And even that's not enough, because if they have to sit and think about which one will be useful, then we've failed them. If they have to think, I want a metric here, and I want to tag the user, and I want to tag the country. Oh, wait, no, the cardinality, that's too high, so that needs to be a log line. No, that means we failed them. It means that we have failed to design a system that's architected for observability. So let's think for a moment. Why are these all separate libraries? Well, they're separate libraries because the storage and query infrastructure is different for each of them. And it's different because of performance. Because in order to actually efficiently emit, store, and query these different types of data, we need radically different storage and underlying implementation mechanisms. Because statsd and Graphite isn't capable of handling the load that we need to send it to give it our log volume. And Elasticsearch, it's not set up to index data the way we need in order to get request-level traces. But we're engineers. We know that implementation details should never dictate the way that we interact with something, because that's a recipe for bad usability, just as we saw a moment ago. So there are three types of data that we're sending: logs, metrics, and traces. And if you squint, they're really not all that different. Like, we could really just emit all of our log lines as statsd metrics with the log text as the metric name if we didn't worry about performance. And when we structure logs, we're just creating key-value pairs, which are essentially statsd metric tags. And traces are basically like metrics as well. The only difference is that they're aggregated in a special way. We're tagging it with the trace ID and the span ID and the parent ID, and we have to do a special graph-level inner join on those to reconstruct the call tree. But they're fundamentally not that different in terms of the shape of the data. So what if we just had a single interface for emitting all of these? And we could decide later on how to handle and how to represent them. So I call this my I want a pony slide, because I don't just want one pony, I want 3 ponies. I want metrics, I want traces, and I want logs. I want all 3 all the time. Well, it turns out we can do this, because at Stripe, we're in the business of making simple, unified APIs over complex legacy systems. And we're in control of our data ingress. We can have an intelligent pipeline that operates on this full fire hose of data. From our service, we emit a single particle of data, which contains the union of that information. At Stripe, we've dubbed this the SSF. It's our standard sensor format, or when we're feeling a little bit cheeky, it's our sensor sensibility format. All we have to do is make this easy and convenient for the developer to emit all this information with just one short line. And then our pipeline can determine how best to aggregate and synthesize that particle of data. So this is just an example. It'll look a little different in different languages. I don't even remember how many lines that the previous one was, but you can obviously see here it's a lot shorter now. We've combined the metric name and the log name because they serve the same purpose. And previously, we were tagging the metric with the success Boolean and logging the query parameters, so we sent them to different places. But here, we can put all that information in one place and not worry about which will get pre-aggregated and which won't. We can let the pipeline handle that decision-making for us. So Veneur will take a stream of SSF particles for us, and it decides not just where to route them, but also what to make out of them. Each particle here contains the full amount of information, but each icon is telling us what Veneur is going to use it to build. So Veneur takes that SSF particle right here, that first one, and it emits both a log line and a statsd metric from it. This next one here, it was about to do the same thing, but it noticed that the dimensionality of the different tags it was being given was just too high. So it drops the metric, but it still keeps the log, so we still get access to some of that information. And then, this one gives a log and a trace, and then these 3 are interesting because it gives us a log and a metric, but it also is smart. It notices that these 3 pieces of data have the same shape, so it's also able to extract a histogram from that and give us a derived metric. It tells us, here's what the shape of the aggregated data looks like as well. So we're not going to send our full log data to Datadog or to Graphite, and we're not going to send all of our tracing data to Elasticsearch, but we know which SSF particles were used to build our histogram because we're the ones who are building that with our pipeline. So if we want, we can record that relationship. And that allows us to integrate our monitoring tools together much more effectively. And that's the crux of it. Veneur and intelligent observability pipelines are not a replacement for any of these tools. They're pipelines that let you integrate them together and leverage them even better. Veneur will use the SSF particles to build the data that tools like Papertrail, Elasticsearch, Grafana, Datadog, Zipkin, Open Tracing, all those tools will present for us in a usable form. And the developer no longer has to decide at the time that they're writing the code how they want to see the data represented when they ultimately will be operating it. They just need to make the decision to instrument it, and the pipeline handles the rest. So let's see some examples of what it means to be able to leverage these tools together more effectively. We can get some integrated views. So going back to the beginning, before we had this graph that showed request timeouts, and we could filter by the fields the metric is tagged with, but we couldn't de-anonymize this data. We had to manually reconstruct the log search term that corresponded to more or less what we were seeing here. And that's painful and inconvenient. If you asked me to do this again, I probably wouldn't be able to come up with that regex. But remember, we own our pipeline, and our pipeline is aware of the relationship between these metrics and the logs because they're emitted from the same SSF particle. So we can layer our own extensions on top of these tools that allow us to link back and forth. So that link right there, which we've added, that will bring us to the corresponding view in our logging system. And it'll automatically construct the exact query that corresponds to the data that we currently see there. So again, it's not a different tool altogether. It's just an integration between the existing tools that allows us to leverage the powers of each other combined more effectively. Another example is in how we make trade-offs with our observability tools. In general, we have to trade off between accuracy, precision, and performance. That's a fundamental property of engineering, engineering observability at large scale. We can't do away with that trade-off, but we can ensure that the trade-off works in our favor at each step. And aggregation is a good example of this. Let's say that we're analyzing API latency. You're not going to look at the latency of every single individual request. That's just too much data to, even as a human, you couldn't actually make any reasonable sense of it. So when we look at it, we analyze aggregates. We think of things like averages or medians or the 99th percentile. Those are indicators that capture some of the qualities of the data, but they're lossy. They don't give us the full shape of the data. They just give us the general shape. But even if we have a trade-off, the point of an intelligent pipeline is that we can stack the deck in our favor. And we can ensure that if we do have to drop some parts of the data, we only drop the parts that we don't need. We can make those decisions more dynamic. We can push them closer to the code and make them work in our favor. So let's see an example of how an intelligent observability pipeline helps us make more intelligent trade-offs. Well, we have an availability issue. If our observability pipeline goes down, you're hosed. You don't have any visibility into your system. So our pipeline needs to be highly available. So we use a distributed and tiered architecture. Every single box in the fleet runs its own copy of Veneur. So that gives us a nice property, because as long as the box is running, that means that we know it has the ability to report its own data. In a Kubernetes world, each box here is actually a pod that runs the application container and a sidecar container. But this gives us now an aggregation problem, because if we want the average latency, we just have to collect all of those latencies, average them together individually, and then send those averages downstream, and then we can average them together, because averages work like that. Unfortunately, percentiles don't. Medians don't. You can't combine medians. They're not monoids. There's not a mathematical operation that will allow you to take the median of medians and give you a valid result about the global set of data. It's just not possible. So if we wanted to get a global percentile, we'd have to send all the data to a global box to be aggregated, which defeats the whole point, because now we've reintroduced a single point of failure. If that global aggregator goes down, we're stuck. But we've also introduced a load problem, because now we have to send all of our request latency data to a single box, and that's a lot of data. With Graphite, way back, we actually were running Graphite, and we tested this out. We ran as just we ran a single heartbeat metric that we sent downstream to our global Graphite instance, and we found that we would drop 70, like 50 to 70% of our heartbeat metrics on the floor because it was just overloaded. So to solve this, we use, as I said, a distributed and tiered infrastructure. We use a consistent hashing scheme, so we have a number of different aggregator boxes that will run in parallel, and we use a consistent hashing scheme to ensure that all of the different metrics of a given kind that need to be aggregated together will get sent to the same box. So the host 1 will always send the red metric to the first one, the blue metric to the second one, et cetera. And hosts 2 and 3 will also always send the red metric to the first and the blue to the second, and so forth. This means that we can horizontally scale our aggregation, and we can also ensure high availability, because if any aggregator box goes down, that's fine. We only lose the aggregates on that one box. The other n-1 are fine. But we can actually do better than that. Now, my background's as a statistician, so this here's the stuff that I could easily spend an hour talking about. And so if you want the full picture, come find me at one of the breaks, and I'll be happy to go into more detail. I'll just give you a taste, though. I said a moment ago that there's no mathematical operation that you can do, mathematically valid operation you can do that will give you the median of medians and give you a meaningful result. And that is true if you're dealing with exact operations. But we can actually use approximations to calculate our percentiles, as long as we're confident that those approximations have the exact properties that we need. And it turns out that there is an algorithm, the tdigest, which do have the properties we need. It allows us to calculate recursive percentiles in an online fashion. So it means that we can operate on streams of data, not on loading all the data in memory, and we can calculate percentiles on each box individually, then send those percentiles downstream to be aggregated, and then we just run the same algorithm there again. We operate on the percentiles as if they were the raw data. Tdigests allow us to trade off variance in the medians for precision in the tails. So if you look at this error chart right here, you can see that there's a decent amount of variance in the median. It's not bad, but it's not great. But once you get to the tails, it's actually pretty precise. In fact, you might be dealing with the exact values at the tails. And that's what we care about, because oftentimes when you're looking at latency, you don't really care so much what the median latency is, as long as you're bounded by the tail end latency. So again, I won't go into too much detail here, but if you're interested in how some of these, how we make some of these trade-offs and how some of these more sophisticated algorithms work, come talk to me afterwards. So let's go back to that story at the beginning. It's 3:07 in the morning. You're paged. You're still not thrilled about being woken up. You're never going to be, but that's OK, because you know that your systems have an intelligent observability pipeline which can do that heavy lifting for you. You don't have to worry about whether the code that you're actually debugging was instrumented, whether the developer actually took the time to think about which pieces and which types of data that they wanted to add to it, because you know that it was easy for them. You know that they only needed one single interface to instrument all their code, so you're confident that you have the proper visibility into your code. And you don't need to tediously reconstruct each separate view of the underlying data, because your tools are integrated. Your pipeline allows you to preserve those relationships and jump back and forth between them instantly, between those equivalent views, without having to come up with them again from scratch. So you're able to locate the source of the problem quickly. You're paged at 3:07. By 3:09, you fixed it. And by 3:11, you're back asleep. If you think that sounds like a better story to be living, try Veneur out. It's free, it's open source, it's on GitHub. We built the first version of Veneur ourselves at Stripe, but we're not the only ones who use it or contribute to it. Sentry and Bluecore are two other companies that have monitoring and runtime data right at the core of their products, and they both rely on Veneur for their metrics pipeline as well. If you're currently using any of the most common tools like Grafana or Datadog or SignalFX or Prometheus or OpenTracing, then Veneur can work out of the box for you. You don't have to do anything. It's just a drop-in addition or drop-in replacement. You don't have to change any of your existing instrumentation at all. To get the full benefits of Veneur, like we talked about today, you'll probably want to start using instrumentation like the SSF. But as a start, Veneur is capable of working with your existing setup. We run on a six-week release cycle, and we do provide native support for Kubernetes for those of you interested in that. So take a look. Through our work and through the help of others, we've achieved a lot with Vinner already. But as I said, there's a lot of work left to do if we want to make intelligent observability pipelines universal and the gold standard across our industry. So let's do this. Let's make the gold standard of observability, which is fully integrated observability tools, accessible not just to the Googles of the world, but to hobby projects and to companies of all sizes. Thank you.
Thank you. Thank you so much. That was great. And if everyone is just blown away and suddenly like, oh, we started the morning super techie, like, yes, you're at DevOps Days. This was exactly what I think sets the tone for, all right, we are building systems, they're complex, but we can make them observable and understandable. Thank you so much, Aditya. All right, give it up one more time for Aditya. Okay, and then Debbie was going to come and have a few more of our sponsors say a few words to us. Unfortunately, I think I need to find Debbie, but come on up. You have a few words to say.
Hello. We got Sumo Logic here. Could give a little pitch.
Hi, thank you. I'm Drew from Sumo Logic. Really nice to be here, thank you. So if you're not familiar with Sumo, we are a multi-tenant, cloud-native machine data analytics company. If you're not currently have a logging platform today, or you're struggling with the one you have, or you want to come by for a squishy, just come by the booth. We'd love to talk to you a bit further. So thank you. It was nice seeing everyone. Hope to see you later.
By the way, I'm Scott. I'm one of the sponsor coordinators, and bringing up to the stage now Tor from SPS Commerce. Thank you, Tor.
Hey, everybody. My name is Tor Flatabo. I work at SPS Commerce. We're super happy to sponsor DevOps Days. We've been doing this for a long time. And one of the things that I really like about this conference is it's kind of a recognition that, one of the things that we're going to end up having to do is DevOps. Most of us work at a company who have customers. We have tens of thousands of customers. We run millions of documents through a month. And we do billions of dollars of revenue for our customers. DevOps isn't really an option. It's something you have to do. When you get to a certain amount of scale and a certain amount of latency and customer expectations, it's just something that is really, your customers kind of expect you to have everything working. We're in downtown Minneapolis. We have over 1,000 employees at our company and hundreds of people in our engineering organization. We have many positions open, and we're doing really fun things with a whole bunch of great technology. We're mostly in the cloud, and we have a really great build-deploy pipeline that's really fun to work with. So if you're looking for doing DevOps at scale, doing engineering just at scale, and doing really fun things and solving really hard problems, please come and join us at SPS. We're right in the vendor room. Come talk to us. Thanks.
Okay, please welcome Damon from Rundeck.
Good morning. So show of hands. Who loves working with tickets? Opening tickets, closing tickets, waiting for somebody else to do? Oh, one guy. Okay. The rest of you probably not, right? New question. Who loves the idea of fewer tickets and more self-service? Anybody? Yes? All right. So Rundeck is for all of you. Rundeck makes it really easy to take your existing tools, scripts, commands, API calls, whatever you've got, connect them together and create standard operating procedures, and then give out self-service access. And what people get really excited about with Rundeck is letting people who are traditionally outside of the privileged operations world have self-service access to privileged operations tasks, right? So developers doing restarts in production, business analysts doing things, QA folks doing things. It makes it real easy and secure. The auditors love it, and it makes everyone's life a whole lot better. So if you're interested in talking about how to transform your operations, we're in the exhibit hall just over to the left. There's an open source version, there's an enterprise version, and we love talking to everybody. And thanks a lot to the DevOps Days Minneapolis crew for such a great event. Thank you.
Thank you, Damon. Please welcome Tyler from PagerDuty.
Good morning. How many people have heard of PagerDuty before? Okay, cool. So we are hiring right now. We have 2 engineers here who work for PagerDuty. If you want to hear more about what it's like working here, We also have some new features, so stop by our booth to come check those out and enter our raffle. Thanks.
Thank you, Tyler. And please, again, welcome Adam from Morpheus.
Thanks, Scott. Okay, show of hands again, audience participation time. Who's heard of Morpheus? Okay, great. Welcome. This is our third year in a row here at DevOps Days Minneapolis, so thanks for having us. We are a cloud management platform built by a private equity firm to support their developers. They were doing that for some of their companies that they sold off. Those guys said, hey, this is better than what's publicly available. Can we get a copy of it? I said, oh yeah, sure. So what we're targeted to do is to give developers self-service provisioning to containerization, virtual machines, bare metal servers, cloud resources, really anything you want anywhere. So we're sitting over here in the sponsor area. Come get a badass t-shirt, and thanks for coming.
Thank you, Adam.
Thank you so much. Yeah, it's funny. I was scanning looking for Debbie because she was doing it yesterday, didn't even see Scott. It's nice when you have enough people to help that you don't even notice that they're there. Okay, so our next talk. From the size of the Kubernetes workshop that my coworkers were running yesterday overflowing, I'm guessing that a lot of you are thinking about kubering some netties. But you may also be concerned, right? You may see news articles about major players like Tesla somehow having cryptocurrency mining happening because they kubered some netties. And you're like, how can I do this but do it well and not have it be a horrible disaster? Good news. Ian Coldwater is ready to talk to you about this because they have actually done this and are also a security professional. So all of you who want to kuber some netties, but then security says, you can now find out how to do it well. So please, warm welcome for Ian Coldwater.
Wow. Hi, everybody. I'm really excited to be here. DevOps Days is my favorite tech conference anywhere. And Bridget's amazing. Can we all just give a hand to the organizers really fast? So my name's Ian. I'm here to give a talk about Kubernetes security. I do DevSecOps at Jamf Software, where I focus on container security and hardening cloud infrastructure. I'm also an ethical hacker. I've been hacking since I was a kid. As an adult, I travel around the country playing capture the flag games, which are like ethical hacking competitions. This stuff's fun for me. And besides it being fun, I think coming from an offensive security background has made me a better defender. Because being an attacker teaches you a different way to think. Often developers will assume good intent and make features for an ideal user to be used in exactly the way that they want them to be used. And that's great. Assuming good intent is a great practice and often a good personal quality. But in fact, not all users have good intentions, and many of them might not use things in the way that they're intended. And so a thing that's important for us to consider is how to be able to think like an attacker in order to be able to secure things from those users. Attackers have user stories too. As an attacker, I'm here to tell you some. As an attacker, I want to pwn you. So, because of the time constraints we're under, this talk is long on high-level abstractions and short on technical deep dives. We barely have time to scratch the surface about Kubernetes security in half an hour. It's a big topic. But if you're interested in learning more, and I hope you are, I have a resource as a slide on the end. But first, before we tell some attacker stories, let's set the stage. In the beginning, there were virtual machines. And virtual machines were very useful for people who wanted to be able to build things that required different operating systems or different dependencies from the things that they we're working on the host, but they came with a lot of resources and a lot of overhead. So containers happened. They don't always contain kittens, but perhaps they should. And containers are not tiny virtual machines. What they are is they share a kernel and have namespaces to separate them. And containers are great and very useful. You can package all of your application and all of its dependencies, everything you need in together, but they have some problems. They don't necessarily communicate very well on their own. They're difficult to scale in an automated way. And you know, if you're trying to share resources like a database or anything like that, hi. Okay, if you're trying to share resources like a shared database in a microservice architecture, it can be a problem because they're stateless and they don't necessarily do that very well on their own. So in order to solve those problems, people created container orchestration frameworks like Kubernetes, which solved a lot of problems with being able to really scale microservice architecture and its applications in a way that could be easily automated and done by people. It also, as well as solving problems, added new complexity, and like a lot of complexity. Who here thinks that Kubernetes is kind of hard? Anybody? Yeah, I think most people who have played with Kubernetes think it's probably kind of hard. There's a really big learning curve. There's a lot going on there. There's a lot of moving parts. And because of that, one thing that's happened is that defaults for Kubernetes make it so that security is an afterthought. It's made to get people up and running really fast. It's made to be able to like smooth over the learning curve. That's cool. But also, that means that historically, Kubernetes has been wide open for hackers to walk right into. The Cloud Native Computing Foundation did a survey in 2017 that said that Kubernetes was the biggest challenge for security was the biggest challenge for Kubernetes users, and it's that makes sense because it is a challenge. There's a lot going on there, as well as Kubernetes itself being hard. All configurations have they differ according to cloud provider, they differ according to user installation, and they differ according to whatever plugins and add-ons that you're using. And pretty much every Kubernetes cluster is going to be different. And because of that, making it, like hardening, making it more secure, is going to vary really widely. And this has caused some problems. Well, Kubernetes gets hacked. Tesla famously gets hacked. They're going to be the cautionary tale forever in every Kubernetes security workshop forevermore. Weight Watchers got hacked a few weeks ago on a server that just didn't have a password at all. On API, or on open port 10250, which historically has been called the insecure API port. And spoiler alert, it's called the insecure API port because it was insecure. Kubernetes 110 deprecated it. Kubernetes 110 was not that long ago, and a lot of these things still exist in the wild. As anybody who's ever worked on any kind of production might know, what happens in production can sometimes stay in production. And they're still out there for hackers to be able to get. So security is hard. It's hard to secure it, it's hard to keep it secure, and it's easy to make mistakes. Not only is it easy for us as developers and operations people to make mistakes, even hackers can make mistakes here because shit's difficult. Besides, which is kind of like DevOps Days for the security community, did a capture the flag competition a year or two ago, it's 2017, and they left their backend wide open. So somebody who presumably had more experience with Kubernetes infrastructure than the people putting on the CTF walked right into the back of it, took all the flags, and then handed them to them and said, you need to fix your API. So it's not just you. We all make these mistakes. Kubernetes has a very active community of contributors who are pushing changes very fast. And in recent versions, especially after like 1.6, and especially in the last couple, security features have improved a lot. So if you are still running 1.6, you really shouldn't be. You should really update that. And you know, if you can patch it, patch it. If you can update it, update it. It's really improved a lot. That said, there's still a lot of older Kubernetes releases in prod, and they're wide open for people to discover. How to attack those and how to defend different Kubernetes clusters varies the way you configure it. I have good news and bad news for you. It is actually possible to secure Kubernetes clusters. The bad news is it's not going to be secure by default. The other bad news is security doesn't actually end there. You have to make sure that your hosts, the platform it's on, your public cloud, are also secure. So you need to make sure that, for example, your kernel is safe from Meltdown Spectre type attacks. And you need to make sure that your public cloud has appropriate IAM roles applied to it. You can do this, but it will take some work. And you have to do this because there are bad people out there who actually do want to attack your stuff and take it. They have different motivations, but they're out there. And they do have some things in common. Hackers don't give a shit. They don't give a shit that it's an internal system. They don't give a shit that it's hard to change. They don't give a shit about your business case. They do not give a shit about your constraints. Full stop. They don't care. That's your problem. As far as they're concerned, that's great. They're very happy with that. Is there water anywhere? So I'll leave that up for everybody to appreciate for a second. And different hackers do have different motivations. Some of them might be motivated by money. Some of them might be motivated by ideas. Some of them might be motivated because they don't like you. And your threat model is going to differ depending on what it is that you're afraid of. What is your threat model? It's important to consider it. Are you concerned about external attackers from outside? Are you concerned about attackers specifically targeting you? How skilled are your adversaries? What are your capabilities in being able to protect against them? Targeted attackers are going to be more determined, possibly harder to stop, because they really want to get into your system and attack you. And depending on their skill level, that can be complicated. If you have nation states after you, you might be in deeper shit than your average fancy bear. But if it's external attackers, who are just looking for open ports on the internet, a lot of the time they just want to, do their thing and go, and they're going to pick the easiest target with the lowest hanging fruit. If you aren't the easiest target with the lowest hanging fruit, they're not necessarily going to be interested. There's 1,000 other systems or millions or whatever that they can come find. So if you can be like, I'm not an attractive target, that's good for you. That may be bad for me as an attacker. So consider your threat model. What are you afraid of? What are you trying to protect? In general, Kubernetes threat model is external attackers, application or container compromise, or a compromised user or credentials. And there's different ways to protect against all of these things. Generally speaking, regardless of her motivations, every hacker is going to have roughly the same kind of workflow. They discover it if they're external, or maybe they already know it's there if they're targeting you. They're enumerating what is on that server or whatever it is that they're looking at, what's running, what services are in there, are they patched, what versions are they running, is there some vulnerability or CVE there that you can find, and okay, so is there anything exposed, what's running as privileged, what's connected to what, is there wider internet access anywhere that I can go download some malware from and put it in there? Are there credentials or are there secrets anywhere? Those kinds of things. So trying to figure it out. Once you figure out what's vulnerable, and there is usually a vulnerability, to be real, then you get your initial foothold. You do the hacker voice, I'm in thing. And then you kind of look around some more, figure out what's in there. If there's anything interesting you can steal, if there's anywhere interesting you can go. It's like, what can I do here? Is there anything I can loot? Is there anything I can access? Where can I go from here? And then you kind of do the same thing again. Can I escalate my privileges here? Can I get root? If I can I get root on the host? Can I break out of this container? Can I just go wander around your AWS account and throw a crypto miner on it? Maybe. Let's figure out where we can go. And then you just keep doing it as you get farther and farther. And then, eventually you can't get farther anymore. But a lot of the time by then, it's already game over. So you want to make sure that you're stopping hackers from being able to get anywhere, really, but being able to get very far. Because the farther that we are able to get, the more we're able to compromise and the less you're able to protect your own resources. So, if you're an external attacker and you're looking for things to attack, there are different ports that Kubernetes leaves open, often by default, that I might look for. So some of them could be things like the insecure API server, or the kubelet, which older versions of kubelet were pretty much direct root into the container. And to this day, depending on what cloud provider installation you're using, can still be that way. It can get around pod security policies and various other things if it is configured incorrectly. So I'm going to be looking for what's open. etcd, older versions of etcd had everything in clear to text, including all passwords, all database stuff, all metadata for all your cloud providers, all of the everything. So I'm looking for that. I want to go in, get what I can get. And you might think, I'm not a target. I might be too small. I might not be making, nothing in here matters. You can't find me. You're wrong. Who here has ever heard of Shodan? Anybody? A few of you? So Shodan is basically like a search engine for the internet. And you can go on there and search for things like open ports anywhere in the world. I did this search on Shodan last night because I wanted the most updated number. As of last night, there were 1975 open etcd ports on the wider internet. A few of them, I managed not to screenshot any of them, had things like SSH keys just chilling in there, and various other kinds of credentials. And I'm not personally interested in a CFAA case at this point in my life, so I didn't go follow them. But you should know that it is actually just as easy as putting this thing in the search bar for people to find your SSH keys and other kinds of things if you're not securing them properly. So secure them properly. Don't leave your ports open if you don't have to. Shodan re-indexes every 24 hours. A lot of the SSH keys were several hours old. Probably by the time I got around to seeing them, other people had also seen them and gone about attacking them. It doesn't take long, so just don't do it. Just don't leave your stuff exposed. Make sure that if you do have anything exposed, visible externally, that it requires authentication. Because that's not necessarily the default, especially with older versions of Kubernetes. Put TLS on absolutely everything. This is very important, because if it's clear text, I have it. And limit SSH access to Kubernetes nodes, because otherwise I can just wander right in there, especially if you're doing things like leaving your SSH keys open on Shodan for all the world to see. And if you need SSH access to some of your nodes, you can create something called an SSH bastion for the ones you do need. It's been said that defenders think in lists while attackers think in graphs. And a really important thing for you to consider when you're thinking about securing your Kubernetes cluster is what's in your graph. And this is a deceptively simple question. Do you actually know everything that's in that cluster? Do you actually know everything that's on your public cloud account? You might not, especially if you're in a big enough organization, perhaps with silos or communication or process issues that can make it hard for people to know what other teams are doing. It can be difficult or impossible to find that out. But as an attacker, I'm determined to find that out. So compliance might be satisfied with checking all the required boxes in the checklist, but that isn't what I'm looking for when I'm in a network. I want to know what's in there, what's connected to what, where I can go from here. And for you, as a defender, what you need to do is make sure that you know what microservices are communicating with each other, even within the cluster. You need to be able to define and map out what exactly is talking to what. and with which types of requests, because that can allow you to define and lock down network communications. Understand how your app operates. Understand how all of the services work together. And always remember the principle of least privilege. The more that you limit information disclosure and things talking to one another and talking to the rest of the internet that don't need to be, the better shape you're going to be in and the worse shape I'm going to be in as an attacker. So another thing that I could do as an attacker is try to compromise credentials or users. Computers are dumb pipes. If I have your credentials, as far as the computer's concerned, I'm probably you. So there's a few different ways to do this. If I am trying to social engineer a developer, which developers are actually great targets because they don't think that they're targets. They have a lot of access to things like production servers and keys and cloud metadata. And because they don't think that they're targets, they're actually more likely to click on phishing links than marketing or sales. We should all be embarrassed about this. So social engineering can totally happen. If I manage to convince Joe Developer that this link is very important to click on, fantastic, I got it. If I can publish a helpful blog post saying like, oh, here's this really hard thing to do a service message, nobody understands the service mesh, like let's be real. So here's this really difficult thing that very few people actually know how to do. And the way that you do this is you just install my Docker image. kubectl, create, -f, evilscript.yml. And you can totally do that. That's great. Just get my image down from Docker pull. That will help you. It'll walk you through the tutorial. It'll be fantastic. No, because actually, it'll be fantastic for me. It won't be fantastic for you. And it's really important to not fall for social engineering. And it's really important to know what your image is and what your code is doing. Don't just throw a YAML file into your cluster without actually knowing what it does. Actually read the code, understand it all the way, and look closely at it, because we can do things like kern our letters such that it, looks like it is actually different letters than it looks like it is, or obfuscate it so that it looks fine, but it isn't. So limit access to your credentials, and don't fall for any of my crap. Containers are also fairly easy to compromise, and container compromise can lead to bigger attack surfaces. And those bigger attack surfaces can expand beyond the containers into hosts and into public clouds. The Kubernetes control plane contains various kinds of vulnerabilities that are really important to know about. The API server, as you can see, connects to kubectl, the master node, and the worker node. And if you have the API server, you have it all. And the API server historically is wide open. The defaults are such that you can just wander in there. That's not necessarily the case anymore, but you need to be updating, and you need to make sure that you're configuring your stuff correctly. etcd has all of the everything for Kubernetes in it. It has all of the things that control all of the things. And it has database information, it has credentials, it has everything else. Historically, it's plain text. If you have etcd, you have the rest of it. A lot of these things are able to be controlled by kubectl. They're able to be controlled elsewhere in the cluster if you have access to open kubectl. The way that this gets prevented is by limiting communication and movement between different parts of the cluster. So lock your network down, lock your cluster down, and make sure that you are only allowing things to communicate that should be. Really just keep it on a need-to-know basis. Because if you don't keep it on a need-to-know basis, shit can happen. A cool thing about shared kernels is that there are also surfaces for shared kernel attacks. So if I have Meltdown or Spectre on one part of your container, or on a container anywhere, then I also have Meltdown or Spectre on the rest of the containers and the host that it's on. And if I have root in a cluster or a container that's running as privileged, y'all, don't run your containers or your clusters as privileged. Just don't. It's a bad idea. Because the way that the entirety of the Linux file system works is everything is based on namespaces. Everything is a file. And so if I have access to the namespace, root in that cluster can also be root on the host, especially if you're mounting something on the host into the cluster, which is a terrible idea, especially if something is running privileged, because I can just wander in to the rest of the cluster with my write access and write stuff right up in there and also read it and also take it. You can prevent container compromise in various ways. Write your own applications as securely as possible. I know it's hard. We have a lot going on, but try. Look into resources like the OWASP Top 10 and other kinds of secure code resources. Try to figure out how to do that well. Treat other people's code with caution. As I said, like, watch out for evil.yml files. Make sure that your dependencies and the images that you're dealing with are actually good and not bad. Run static code analysis on your applications and containers to check for vulnerabilities, and do that periodically, because only doing it once is just a timestamp for that moment in time. So if 6 months ago that was fine, but 24 CVEs have come out since then that affect things in your cluster, it's probably not fine anymore. So you have to keep doing that. And there are tools for this that are open source. Claire by CoreOS is a really good one. And if you find vulnerabilities, patch or mitigate them. Don't leave them there. This is especially an issue with container infrastructure, because immutability is a feature, not a bug, most of the time. But if it means that every time malware knocks your container down, it just comes right back up with the same malware, that's not necessarily a positive thing. Basically, you want to practice defense in depth. You want to reduce your attack surface to make it so that there are as few ways for me to get in as possible. Lock down your networking, lock down your secrets, restrict communication, put quotas on your resources, and just generally make it so that I'm going to have a hard time getting in there. And if I am in there, you want to limit your blast radius. So make sure that I can't get as far as I can, so that I'm not getting into the rest of your cluster, I'm not getting into your host, I'm not getting into your cloud account. If you can, make it so that it's hard for me to get in, and then make it so that I can't go anywhere, I'm going to have a lot less fun as a hacker, and you're going to have a better day as a defender. I pushed the wrong button, and that was the laser pointer. Sorry if I pointed that at you. And follow the principle of least privilege. I've said this more than once, but it's really important, because it makes it so that I can't escalate if I don't have it. And I want to be able to escalate, but you probably don't want me to. There are different kinds of controls that you can use to do these things, which I have basically no time to talk about. So I'm putting a list of stuff here, and you should take a picture of it or whatever, and then Google all of them later. And look at the things on the resource slide about how to do that, because every single one of these is an hour-long talk, at least, in and of itself. You want to, as I said, put TLS on your APIs. You want to limit access to those APIs, especially if they're insecure, to the kubelet, to etcd. You want to limit your privileges available. Control what pods nodes are allowed to access. I pushed the wrong button again. And you want to make sure that your keys are being rotated, that your secrets are being encrypted, and that you are not having things that I have persistent access to. Because if I can put a backdoor in your container, in your cluster, and it's just chilling there, I can keep going in there, but you probably don't want that. So some general recommendations are, if you can upgrade to a newer Kubernetes version, I know backwards compatibility is often hard, and in enterprise can often be complicated for other reasons. But really, if you can, please do that, especially if you're running anything 1.6 and below. Everything by default is wide on open in 1.6 and below. And even after 1.6, even in recent versions, everything is not necessarily secure by default, especially with things added onto it like Helm Tiller, COPS, various things that I think are actually fairly commonly used are wide open by default with no authorization required. You have to put that there. If you're using those things, make sure to put them there. Secure defaults, if you walk out with one thing here, are really, really important. Because once that default is there, once it's running in production, once people are used to it being there, then it becomes a problem to do anything else with it and add secure features. And then you just stay insecure. And if you can make your stuff default out of the box, if you can make your default secure out of the box, then you don't have to worry about that kind of compatibility later. Be careful with your secrets and your credentials where you put them. And make sure that you're logging and monitoring and paying attention to what's going on. Observability, as we all know as DevOps people, is really important. But your logging and monitoring should not actually go inside the same cluster that I have access to, because I'm just going to delete it, and then you won't know that I've been there. So you want to make sure that those audit logs and monitoring are happening, or at least being doubled somewhere else, so that you can have a more accurate record that I, as a hacker, don't have access to. The TLDR is basically a lot of this really is basic security advice. It's like old school IP tables firewalls, you know? It's things that we've all heard before. Defense in depth, principle of least privilege, the ideas of, you know, limiting your attack surface. This advice keeps being given over and over because this advice is important and we should all be doing it. Unfortunately, we're not always doing it, which makes things great for hackers, but might make things harder for you. So do those things. Practice good cyber hygiene. Get your basics right. If you can make it so that it's harder for me to get in there, you are making it so that you're that much more secure where you are. And you got this. I believe in you. You can do it. Here's my resource slide. There's a bunch of stuff on there. And there's a lot there. The CIS benchmarks are a 276-page document. But it's worth looking into, and it's worth getting into these things in more depth, because it does take work to configure this stuff. And you can figure it out. I believe in you. And that's it.
Ian, that was amazing. And it was really important, I think, for people to hear that we can do this. There is a lot, but we can do this. So thank you so much. All right. I know that we had a little bit of a hiccup there with getting the sound right, but I want to just give one more round of applause to Ian for this absolutely amazing talk. So. Okay. All right, we are going to go to a break. This is your opportunity to go interact with the sponsors, get yourself into all those raffles. You definitely are going to win. I believe in you. And we are going to be back here. Come back at 10:45. We're going to start up again, and we're going to hear about technical decision making, and we're going to hear about the machine learning, all of the buzzwords. So come back at 10:45.
DevOps Days Minneapolis participants, please take your seats. Our program is about to begin.
That after lunch we will have open space in here. We will also have workshops after lunch. The workshops are going to start a little bit sooner than they did yesterday. So you'll have a short window of opportunity to make decisions about workshops versus open space. All right, so the next speaker, as you may have noticed that making technical decisions is hard, and sometimes you need to see how other people do it. I think the first time I saw Amy Chen speak was at KubeCon this past December, I want to say it was. So I saw her speak at KubeCon, and I was struck by how approachable she made a difficult topic like Kubernetes. And so I was very excited that she was able to come here and talk to us about walk us through the product decision making in terms of, and this is key, iterative technical decisions. So please give it up for Amy Chen.
Hello, how is everyone doing? It's been 2 days, so I'm like, hopefully y'all still have energy and have enough attention span to pay attention to my talk. So my name is Amy. I work at Heptio. I'm a systems software engineer. So day to day, I work with things like Kubernetes and Docker and Go, and I really love everything related to distributed systems. In my free time, I also run a YouTube channel called Amy Codes, where I talk about software engineering and distributed systems and all that fun stuff. And you can find me on Twitter at the Amy Code, but you'll see that in the right-hand corner on all of my slides, #branding, soon enough. So today, I wanted to talk to y'all about iterative technical design, because we as software engineers sort of suck at keeping everything that we need to keep in mind for implementing a feature and product. And I'll talk about what things that we suck at keeping in mind and then how we compensate for that. So this is a lovely diagram I drew. Please do take photos of it, because I put so much effort into it. When implementing a feature or creating a product, code is sort of just the peak of the iceberg, right? There's so much more that goes into that. And we as software engineers sort of have this tendency to glorify code, where like we think that because code is the end product, it's like the most important thing. What I'm trying to say to you is no, code is definitely the easiest part of creating product or feature. I'm not saying that coding is easy, but it's the easiest part of this whole process. And it is also the most error-prone, and so it should be your very last step. You need to collaborate with wonderful people like your product managers. So for instance, what are your product requirements? Who are my users? Are DevOps people my customers? Are there, end market customers? Is internal employees my users? There's a lot of stuff that goes into this, right, in terms of the product manager role. And you as a software engineer, there's no way for you, like buried in all this code, to be able to have this perspective. And then we also have to collaborate with designers. So once we have determined what the product is going to look like, how will my users interact with my product? Is it via CLI? Is it via a UI? And then if you do have a visible interface, like a UI, then you also need to interface with front-end engineers. So what is the pass-off point with your front-end engineers? What kind of data and in what format am I going to pass it back to my front-end engineers? You also have to collaborate with SRE. So you need to think ahead before you implement something. How will my product go into production? What are things I need to be aware of? What are implementation details that I need to be able to hook up to at the very end before I think about implementing anything? You also have to think about management, right? I know that we hate this word, but there are timelines, maybe even deadlines. What engineering resources do I have? Do I have other peers collaborating with me? Do I have other headcount to be able to collaborate on this feature or product? Can I split up the work so that we implement this faster? Like what sort of scope is this project, right? So there's so much stuff. Code is the very last thing. Cool. So you have an idea. That's great. Awesome. Now what? Right? So today, what we will do is explore one way that I lay out ideas. But before we do that, let me talk about something that you should not do. For God's sake, do not sling your code. It's like very, like the way I phrase it is, PRs are a very bad way to convey your ideas and collaborate on them, right? I don't have a lot of time. I do a lot of things, and like, I don't have a bajillion hours just to sit there and like trace what your code frickin' does, right? Like, I don't want to like trace up whatever to the root component, the like software engineering design, whatever patterns and stuff that you did. Like, I don't have the time for that. And also, I find code slinging to be an incredibly aggressive behavior. Like, you don't include anyone for input on your implementation. And also, for you as a software engineer, it is now very hard to go back and change the code when people have suggestions on your PR, because there's already sort of like a mindset and way that you've implemented this, right? And so it's both a hard time for your peers and it's a hard time for yourself. So let's talk about the everything else part. And the everything else part is everything that happens prior to and after you write your code. So prior to writing your code, you can think about things like handoff points, and honestly preventing shitty ideas, because that happens. Feedback, which can be told kindly and in a constructive way via feedback. You need to think about testing and think about deadlines, product roadmaps and requirements, security, because I'm not super great at security, and we actually have a security person to think about security-specific things, because you can, have very specific verticals of roles to think about these things for you. And the main thing I want to convey is that code is not just code. Code is a manifestation of ideas that your team has already pre-vetted and collaborated on, and it's very much a discussion, right? Yay, design docs. So this is one way to capture the everything else part. Obviously, there's like conversations and things like that. This is sort of like a formalization. And at work, we just collaborate on Google Docs a lot and have meetings about them. So writing a design doc is one option to flesh out ideas with your team before you code. If your design doc is rock solid, then your code implementation, your time estimation, your testing, productization, all the things related to monitoring and all that stuff will be very smooth because guess what? You've already thought about it. You have a plan laid down to follow. Also, brains are stupid, so when you're implementing things, I sometimes wander off, most of the times actually. So design docs help me recheck that I'm staying on path of what my original idea was. And there's always, a feedback loop. Let's say I implement something, hit a barrier, then I can always rewrite the design doc. But the idea is that you have this core tenet and truth, right, to follow. So I live and die by my design docs. So yeah. So right now, what we're going to do is talk about the anatomy of the design doc and sort of walk through this with a specific feature that we want to implement together today. So I'm just going to go through this quickly. This kind of seems like an English class where we go through what's the anatomy of a paragraph, but just bear with me. I'll have examples in a second. So the overview, we just want a quick 2 to 3 sentences of a description of what we're implementing. For your goals and non-goals, I really like this section because also as software engineers, I think we're very creative and we think of different ways of interpreting the overview of what you're trying to implement. So goals, I think it helps us really hone in on what we're trying to do and why we're trying to do it. And in terms of non-goals, it's sort of contains the scope of what you're doing. So what is the scope of this design doc? What are you not trying to do? What can you push off to later design docs? Background, we can talk about things like the current state of the project, problems with our current state, why we need to implement this new thing that we're doing, and also just resources that other engineers from other teams need to understand the problem space, right? So framing your problem is very important because what's the point of a solution if you don't understand the problem? And then also, talking to product about MVP requirements, and what sort of behavior your feature needs in order to be shipped and called done. Done is a very fluid term, so you should figure out what can be the least done and then what the most done is. And then also in terms of design, then we'll go into talking about architecture. Is there a UI interface? Is there an API interface? And all of those things. Okay, so today what we're going to do is talk about auto-updating software in relation to Kubernetes. And this is just an example of how I went about writing one design doc. So software on Kubernetes, the way that it is packaged, I guess, is today we'll mainly be talking about a deployment in a pod. So today, our goal is we want our software to be able to auto-update itself, and I'll go into more detail in a second. So what is our goal? The goal that we're setting up here is we want to auto-update software similar to how Chrome does it, so that we don't need manual intervention to update our software. It's a pretty easy problem. And our non-goals is we don't want to talk about the mechanisms of versioning our software because I have 30 minutes to talk to you about this and I don't really have time for that. So let's talk about some background of what this is all about, some information that you need in order to think about implementing auto-updating software on Kubernetes. So software in Kubernetes, some background, is that it is bundled in configuration files called manifests. So this is going to be our manifest. So it's just a bundle of configuration files. To deploy your software, we're just going to apply our manifest into our cluster. Pretty simple. What the apply does is just like make sure whatever we define in our configuration file happens. And we run kubectl apply-f config YAML. So another point of this background section is you may be wondering, well, in Kubernetes, why can't you just run something like a deployment update? So for my specific implementation, my configuration includes a lot of different Kubernetes objects that I would like to update and also bundle together. And so that's why we are even doing the auto-updating implementation in the first place. And so we can talk about the minimal viable product. So what is minimum and what is viable? So what we want for our first implementation of auto-updating software is that it needs to be able to update software based on the latest version. And so keep up to date with the latest version. And then also, I need an installation report of whether or not I had a failed or successful installation. Cool. So we have like the setup of this idea, setup of a problem. And now let's go ahead into the design section. I drew this also. Thank you very much. We're going to draw all the things. Especially in the world of DevOps and distributed systems, I get like really annoyed when I see a wall of text because I fully expect diagrams, right? Like DevOps and distributed systems are very much a visual thing because you have different systems interacting with each other and talking to each other. And a picture is 1,000 words. Like, why should I read your wall of text if you can just show me a picture instead? And yeah, so we're going to go ahead and draw all the things. So let's talk about one aspect of our design, which is what the behavior that we want to happen. So once again, we are trying to auto-update our software. Here's an example of a diagram. I sort of forget the name of the style of this diagram, and I couldn't Google it. But anyways, that's besides the point. So we have three components here. So we have our server, we have software version 1, and we also have software version 2. Remember, our software is bundled by configuration files. So what we want for software 1 to happen is this is already deployed in our cluster. And so it's going to constantly ask, well, what is the latest version? Then when a new version comes in, the server is going to be like, OK, version 2. And so then software is going to be like, all right, there's a new version. So let me go ahead and implement version 2. And I'm going to pause myself. Then what's going to happen is software 2, it comes up, right, in our cluster. And then once it's happy and healthy, it's going to go ahead and delete the paused software 1 version. And so I'm not really here trying to teach you about like how to auto-update stuff. This is very much a simplification of like what I actually implemented. But it's like to demonstrate like one diagram that you can do to have different systems talk to each other. And you can see that it's like very clear versus like having a wall of text once again, which I really hate. For this, I didn't really include that much of an interface or an API or UI, but I'm just going to add this here as something to think about. So let's say that you have a client and a server. You want to be able to define the handoff point between the front end, and then also things that need to be displayed within the UI. So for instance, if you're using gRPC, you should define protos and things like that. If you're using REST, all those endpoints need to be defined and what kind of verbs need to happen in order for that coordination between the client and the server to happen. We're going to skip through that. Just wanted to add that there so you keep that in mind. OK. Let's talk about the iteration aspect, because I sort of just described to you the like very superficial behavior of like what was going on in my auto-updating software, right? So first of all, like why iterate? Like what's the point? Well, the reality is that your end user doesn't really care about how clean your software is, or how clean your code is, or how cleverly you did something. Like make it work, then make it great, and just keep on iterating. So our first iteration is we want to have software that updates itself and keeps up to the latest version. Then what we also want to have in our first iteration is we want to have an installation report of successful and failed installations. So let's talk about future iterations, because I feel like this is fun. The reason why we have future iterations is because I think that in terms of the feedback cycle between product and end users is that there's no way for you to know what is best for your end user, because as much as you can dog food your product or your feature, your end user has the exact use case of what they want to use your product for. And so just shipping as soon as possible, or as soon as possible with as much as with the minimal viable features implemented is super important to start that feedback cycle, so that you don't do something super well thought out and super clean, and then later realize that feature or product is totally useless, or that it needs to be more nuanced in some way. So some future iterations that I thought about, for instance, is currently we just sort of apply the entire YAML. And what I would love to have instead is have the server send down only a diff of the updated manifest instead of trying to apply everything. Also, we have a lot of applies, so we can maybe use a list object instead to only see that diff between the Kubernetes objects. Also, what about a controlled release of updated software? For instance, let's say we have a bajillion clusters, very exact numbers. Then what we want to do is, let's say we see 1% of failures, or whatever your error threshold is, then you want to, or let's say a bigger number, 10% of your installations have failed so far. Then you want to have an error threshold so that you don't roll out more releases of software version 2, because obviously there's a bug in it, and you don't want all a bajillion of your customer clusters to be able to have that failed software, right? So that's one idea. And then what about a policy engine? So let's say we want to be able to configure different installations of said software on a cluster. What about pre-flight checks? So for instance, before your installation, let's say this cluster doesn't have enough resources, and they need to scale some nodes or something. Is there enough resources in the cluster? Is the cluster the correct version? All of those things you can think about of detecting prior to installing your software. Cool. That looks like it for iteration. So, the point is that I think as software engineers, we have this perfect idea of what software can look like in our minds. But the reality is we don't have enough time. You may have families. You probably have friends. Hopefully, maybe you have hobbies. And there's not enough time in the day to be able to just code all the time. So having an iteration and an idea of just a quick and dirty, this works, I'm going to continue to iterate on top of it, is important for you to plan out. The other thing I'd like to think about for iteration is that as software engineers, or maybe I should just speak to myself, I hate rewriting code. I would rather just write it so that the piece of code can be nuked later. So then I can, so that I don't have to edit old code and just rewrite the entire component instead. I like to just think about it as a lizard dropping its tail. I was gonna draw a lizard, but I didn't have enough time, so that's okay. Cool. So after all of this, we need to think about failure visibility. So things like monitoring failure, logging, testing, integration testing, unit testing. So for our auto-updating software for integration testing, the way I implemented it was I did it via a state machine. So the other thing I need to think about is, for instance, do I need a mock server to maybe drive some of the tests to happen to see if the software installation actually auto-updates? And just thinking ahead of time of how you test something is super important. And having those tests reflect the reality is super important. I won't go into the topics of monitoring, logging, testing, just because there's a lot that goes into it. And we could be here all day. I think I copied this slide by accident. I think this is supposed to be the end, but thank you very much. And that's what I have to offer to you about iterative technical design. And so I hope you took away some lessons. Yeah, thank you.
Thank you so much, Amy. I feel like there's so much for us to think about there, and I imagine that people are going to want to discuss this quite a bit in open space. So, all right, thank you so much. One more round of applause for Amy Chen. Okay, so we're going to hear from a few more of our sponsors, and I want to make a couple of quick announcements while I have you here. Again, lunch will be at noon. I have another talk coming up after the sponsors. More on that in a little bit after we hear from some sponsors. But I also want to remind everyone that you should be thinking about your topics for open space. Again, we have air conditioning. The lake does not have air conditioning. You should enjoy the air conditioning. Also, important raffle coming at 3 o'clock. All right, and if we want to have these folks come up and say some things. Also, I'm just curious, quick show of hands if you did participate in a workshop yesterday. Yeah, that's approximately half the room. I don't know how you all fit in there. But I think that you want to make sure that if you do want to do a workshop today, you'll want to make sure to get in there kind of early because the room cannot actually hold all of you. Let's see, a couple of other things to consider as well. We have lunch, and then we're serving the desserts in the sponsor lounge. This is not an accident, and it's not a coincidence. It's a calculated attempt to get you to walk past the sponsors and perhaps talk to them. Remember, they bought you the lunch and also the dessert. So lunch is out here, but dessert is in the back of the sponsors hall. Also, and I'm not sure if people have been tweeting or whatnot, but we're definitely going to go back and look on the DevOps Days hashtag and see what people have been saying on Twitter, probably try to find all the other hashtags people made up too. But we're also going to send out a survey, in theory, if I don't forget or I'm not too busy. And we would love to hear what you think, because we plan on having this conference. So if we're going to do it again, we want to hear what worked and what didn't work for you. All right, come on up. Let's hear from our sponsors.
Thank you. Introducing Peg from Merrill, and I'm Scott. Give her a round of applause.
Right.
Thank you.
I want to try to get a selfie up here before I finish, but okay. So hi, I'm Peg Mickelson with Merrill Corporation. I'm Director of Technology Operations. So we are Merrill. We're not Merrill Lynch. We're not Merrill the shoe company. We're Merrill, just Merrill. We are a Twin Cities-based technology company. We have engineering offices in the North Loop in Minneapolis, in Denver, in New York, and in London. Our DataSite One product is the only SaaS application for due diligence. In our DataSite product and our other products at Merrill, we have some really awesome tech going on. I noticed when walking around the sponsor area that every other booth or so is some product or technology that we're using at Merrill. I want to give a shout out to my colleagues from Merrill. If you're from Merrill, raise your hand. Woohoo! So we have amazingly talented, smart, kind, and very fun people working at Merrill. So come join us. We're hiring in product, engineering, cloud, tech ops, and more. And we're hiring junior all the way up to senior level people. So come, remember that it's Merrill, just Merrill. Come for the tech and stay for the people. Thank you.
Thank you, Peg. Now we have John from Red Hat.
All right, good morning and happy Friday. I'm, as I said, John from Red Hat. At Red Hat, we truly believe that open source is or should be at the heart of all digital transformation and innovation initiatives. Red Hat has significantly evolved from its original roots as an enterprise, #1 enterprise Linux vendor. Right? An example of that is we're now bringing you to leading edge of innovation in DevOps with agile, container managed, open source software deployment at enterprise scale on our OpenShift platform. We're also able to help you enable your journey to the cloud across private, public, and hybrid with our virtualization, Ansible, CloudForms, and OpenStack platforms. So now when you're ready to take on that next digital transformation project initiative, we invite you to come over to Red Hat and innovate in the open source way. If you haven't had a chance to stop by our booth, please stop by. We're having a registration. Everybody who registers, we're giving $2 to a local charity, Genesis Works, who's contributing to the underprivileged youth to get them in a track in technology and give them good opportunities. So I thank you for your time today and have a good day.
Thank you, John. Now we have Waldo from Datadog. Here he is.
Thank you. So driving at any speed when you can't see is dangerous at any speed. You need observability and insight tooling. And by definition, those need to be more available than the services you're trying to watch. Unfortunately, it doesn't come free. One way or the other, you're going to pay for it. You can roll your own, hopefully back it as a capital P product in your company, supporting it with a team, or you can pay somebody else to do it for you. And finally, you can choose to do none of it well, in which case you're going to pay for it when things are broken and you need your tools and they don't work. And things will go wrong. They will break. This message of hope is brought to you by Datadog. If you don't know us, we are fine purveyors of excellent conference t-shirts, and we have a lovely side gig of providing insight tooling services. We'll make it easy for you to track your metrics, application traces and logs, and present them to you in useful ways. When you change from an internal combustion engine to an electric engine, you need different gauges. And we can help you with that.
Thank you, Waldo.
Thank you. Good job.
Now we have Shiva from ServiceNow.
Thank you very much. Good afternoon, everybody. My name is Shiva Ramachandran. I am part of the product management team in ServiceNow. How many of you are using ServiceNow or heard about ServiceNow? Quite a lot. There are a few of the people who might not know. So ServiceNow is a cloud-based SaaS provider, and we do IT service management capabilities. So recently, we have branched into customer service management, HR, and security operations. And towards the end of the year, we are coming up with a new product for enterprise DevOps. So what it's going to do is basically give you a single pane of glass that will show you the capabilities of what's happening in your DevOps process, right? From start to finish, what's going on, provide you that information. Plus, it's going to give you the capability to do something which is easy to integrate with your existing tool chain, because you've got a lot of tools for DevOps, and integrate with them and orchestrate this from start to finish. Our powerful workflow engine will help you to do that. And the third thing that will provide you is a capability to integrate seamlessly and easily with your IT service management of your incident, problem, change, and automate that process much easier. So this is something which is coming up. We are investing very heavily on the artificial intelligence and machine learning to make our customer lives much easier. And we are also hiring a lot of folks on the who can build some great products on ServiceNow. So if you're interested, look at the job openings that we have. And last but not the least, if you want to kick some tires and see what ServiceNow is, so join the developer community that's there, and you get a free instance of complete ServiceNow, which you can use it to see what new capabilities and functions and features are there. So thank you very much. It's been a great, awesome 2 days with all of you here. And hats off to the organizers who have done a fantastic job on this one. Thank you.
Thank you, Shiva.
Good job.
Now we have Gary from CloudBolt.
And they're holding me to 1 minute, they said. All right, who's heard of CloudBolt before? Yeah, a couple people, right? So why do you want to listen to me? I don't know if you guys ever heard of Walgreens, Cummins Engine, TD Ameritrade. They all use us to take their journey into the cloud. They have a DevOps staff. They need to get VMs provisioned. They need to have containers out there for them to use. They need constantly changing environments. They use CloudBolt, these large corporations, to orchestrate that, to put in the governance that are in place, to shut down the servers every night, to save on Azure. They do all this via a single portal. We understand the infrastructure that we're going into because we grab it. present it to the end user based on who you are. If you're a marketing person, you say small, medium, and large server. That's all you get. If you're an expert, DevOps folks, I want 2 cores. I want so much memory. I want spinning disk. I got 7 seconds. So please stop by our booth, take a look at CloudBolt. Please register before about noontime for the drone, and I'm right on time. See you guys.
Thank you, Gary.
How's
And
that?
here's Bridget.
How's that? Perfect.
All right. So the time has come where we've got our last speaker who has a few things to say to us. And if you looked at the program, you may have gotten a few spoilers. But Tim Gross, I'd like to welcome you to the stage. Some of you, if you came to DevOps Days Minneapolis last year, you may have done a workshop with Tim. And he was gracious enough to come back and talk to us a little bit about some of the things he has been working on since then. So without further ado, please give a warm welcome to Tim Gross.
My name's Tim Gross. That's my Twitter handle, which is Tim in Hex, and that seemed like a good idea at the time. They didn't stop to think if they should. An alternate title of this could have been Machine Learning and the Internet of Unpatched Things. Or perhaps, because eternal vigilance is the price of liberty, we have to talk about ethics again. Oh, I can hear it now. Is this guy going to talk about the trolley problem? Oh, no. I mean, I just want to code. And who is this guy anyway? He's not an ethicist with a PhD. Why do we as engineers need to talk about this stuff? Why is it especially important to talk about ethics when we start talking about machine learning and IoT specifically? What makes them special? What makes them different from other kinds of software? And the reason that we all need to be talking about this, as Sharon Kennedy Vickers told us yesterday, what we do has impact. Let's look at some examples. Back in March, a self-driving car operated by Uber struck and killed a pedestrian. Now, the NTSB investigation is still ongoing on this, but what's clear is that this vehicle had no business being out on the road. The collision detection system was getting false positives, and so it was causing erratic braking, and so the engineers turned the braking system off. But apparently that message never got through to the field teams that were responsible for turning the vehicle's own emergency braking off. This was a Volvo, I believe it was, nor to the attendee of the vehicle. So the vehicle saw a pedestrian and ran her over. A couple years ago, Microsoft demonstrated their machine learning capabilities with the Tay chatbot. And they let it loose on Twitter to learn from whatever racist trolls wanted to teach it. Now, the experiment was stopped, and this was very embarrassing for Microsoft. Now, clearly, horrible internet racists were primarily to blame here. But the engineers, the researchers involved, failed to anticipate the vulnerabilities inherent in this kind of system. In an IoT example, last year, countless devices in the UK hospital system were taken over by WannaCry ransomware. Patient lives were being put at risk not just because of poor patch hygiene, but because of architectural flaws that allowed access to the devices, and because of flawed incentives in the US government program that developed the malware in the first place. Tesla's autopilot has been, at this point, implicated in the deaths of several drivers. We, and apparently all of Tesla's stockholders, have been constantly reassured that this is the result of improper handling and human error, and not rushing these systems into production before they are ready. You didn't think I was going to leave the home team out, did you? Thank you for your sponsorship. Machine learning algorithms may know more about us and our loved ones than we do ourselves. Target was able to determine from customer purchases, not just when a customer was pregnant, but at what stage of her pregnancy she was in. Apparently, if you buy, women will tend to buy unscented products late in their pregnancy. Who knew? Machine learning is encoding our biases, not just for dehumanizing people online, but we saw yesterday how it can reinforce structures of power and privilege, access to mortgages, sentencing guidelines. We've invited these systems into our homes, and that's kind of funny. But there's almost no oversight into what they're doing. We have unaccountable, closed-source microphones in our homes and are doing who knows what with that information. What all these stories have in common is that, like any other technical failure, there's almost certainly no root cause. These failures are the result of a complex interaction of socio-technical systems and the incentives they set up. It's unlikely that anyone at any of these organizations set out with bad intentions. But as Laneige Sims told us yesterday, your intentions ain't shit. At the end of the day, it's the people in our industry, the people in this room, who are the ones who execute and implement these systems. And the problem isn't just that these systems have real-world consequences. Software always has had real-world consequences. That's why we build it. We can go back to the 80s and look at the Thurek 25 accidents, where software flaws in radiation machines resulted in 3 deaths. The problem is that the consequences of these systems are now being multiplied by their scale. Quantity has its own quality. A huge part of the value proposition of IoT and machine learning is the scale of the data involved. We're collecting a massive amount of data from edge computing devices, and we're processing massive amounts of data in our machine learning models. But the scope of machine learning and IoT is incomprehensible to ordinary users. If you can determine through a machine learning model that someone is pregnant, and not only that, but they're in their 3rd trimester, that isn't a piece of data that anybody willingly shared with you. In fact, most users would be incapable of understanding that you were able to derive that data. This makes creating informed and meaningful consent basically impossible. What makes machine learning especially problematic is, let's see, they're moving my slides here, sorry. What makes machine learning especially problematic is its inherent complexity isn't being respected, only its results. Easy machine learning in 100 lines of Python. Many users of machine learning are treating these things as a black box where numbers go in and results come out. I'm gonna have a little problem here with my slides, sorry. Okay. Oh, my apologies, my notes don't match my, thank you, Joe. Maybe today, the problem with these systems having such complex inputs is that we don't understand the open-ended results that we can get out of them. So perhaps today, someone is using a William Gibson ugly T-shirt to avoid being detected by ubiquitous use of face recognition in law enforcement. But could I give you an innocuous object that makes the system see you as a wanted terrorist to swat unsuspecting targets out in the real world? What happens when a banana looks not like a toaster, like in this sticker, but a bomb or a weapon? When an accident of that kind occurs, do the engineers involved have a responsibility for failing to protect against this kind of side channel attack? The flaws of self-driving vehicles and the organizations operating them are scary enough without adding adversarial environments in the mix. This is some fairly unremarkable graffiti, but it was used to confuse a machine vision algorithm 100% of the time in the field. These attacks are unreasonably effective. The embedded industry, for its part, is stuck in an archaic threat model. They're still shipping devices with shared private keys and with hard-coded passwords, right on the device. We used to say things like, well, if you have physical possession of a computer, it's game over, right? That's actually not the case anymore. We have an answer to that. It's called Secure Boot, where you use the Trusted Platform module on the chip to sign the bootloader and the operating system updates. Your iPhone works this way. But this is treated in most embedded systems as an expensive add-on rather than the default behavior. I want to talk about that in a little while. Existing solutions for IoT over-the-air updates, OTA, are mostly research projects at best. This is a tool called Hawkbit, which, depending on how you look at it, is either an insecure, comically insecure toy or an overcomplicated kit of parts. Or we're requiring trust delegation to third parties, like AWS IoT, which, that screws up your guarantees of provenance and puts Secure Boot at risk. And the problem with our complacency on this as an industry is that it invites someone to do something about it. Like these geniuses. And when they decide to act, the legal remedy is likely to be ham-fisted. We have to do something. This is something. We must do this, right? We've seen this before. And we've seen this in the evergreen fights over encryption, right? Where the government thinks that somehow they can make math available only to good people. And this is particularly a problem here in the US, where virtually all our lawmakers at the national level are either incompetent, or they and their minions are entirely co-opted by interests that are hostile to the greater public. I can't fix that problem. Today, much of our work is protected by, well, you know, we don't actually warranty this for any particular use. This is the Apache license, but most open source licenses look like this, as do most end user license agreements. But these agreements aren't magic talismans that protect us from responsibility, right? This is part of the legal system. We've been allowed to get away with this, and that could change. Does anybody in this room want to carry malpractice insurance for software? But even in the face of very reasonable privacy law like GDPR, we've seen our industry act with a lack of professionalism. We had 2 years of notice on this, and this kind of like, oh, I'm going to take my ball home is the best that we can do. Top post on the Orange site from another GDPR shutdown. What many posters here miss is that a big group of tech people have no interest in dealing with legal matters. Aw, poor baby. You don't actually get to be part of a world-changing industry and pretend that there are no real-world consequences. This is childish. On the other hand, if this is what organizations are doing, then maybe this is working as intended. If you can't do your job to protect the users and have to close up shop, the EU is effectively saying, mission accomplished. It doesn't have to be that way. In this interview with Mark Benioff, CEO of Salesforce, he points out that this could actually be good for our industry. It could set up guardrails. And this is deeply important because we as an industry have failed to set those guardrails for ourselves. And the larger society, our users, are starting to notice. So it's not too late. What can we do? All right, so let's talk about some of the things we could do. Let's talk about consent. Now, consent is really the only working model we have for talking about relationships between individuals, right? I consent to be part of your research. You consent to be in a conversation with me. If you're in a relationship with someone, you withdraw consent. Your partner is supposed to respect that. At this point, you know, we're still trying to drive that through with a couple of thick skulls, but like this seems to be a working model. But consent has some limits once we start getting a lot more people involved, right? Although individual consent is really the basis of liberal democracy, there are some times when we decide that the will of the community overrides the consent of individuals, right? We expect people to pay their taxes. We expect people to get vaccinated. And the boundaries of individual versus community consent vary quite a bit by culture. The GDPR demonstrates that the EU believes that individual consent is protected very strongly and should be. Whereas in the US, we kind of have this mixed bag where it's like, well, businesses are individuals, but sometimes they're given the backing of the community to override individual consent, and maybe not all the responsibility of that. We also talked about how unexpectedly derived data makes consent nearly impossible to understand. When you combine that with dark UX patterns like this, we make this work worse by manipulating consent, right? Well, you know, you agreed to this, but did you really understand it? We also see flaws of the consent model at play when we look at the Uber accident. The woman who was struck and killed didn't consent to be part of Uber's experimental driving program. She was just on the road. She wasn't behind the wheel, certainly. What does consent mean when other human lives are being treated as an externality? Just as an aside, this is the most ridiculous example from Google. Such as the pollination of surrounding crops by bees kept for honey. What coal industry PR team managed to infiltrate this into Google results? All right, the dynamic of community versus individual consent points to a problem defining foundational values. There was a great talk by Brian Cantrell at Monktober, I think it was last year, where he distinguished between principles and values. If we can disagree on things like the balance of individual versus community consent, well, how do we define shared values? Turns out, we're not the first people to have this problem. So how do other professions solve it? Sonia Gupta, who was on stage last night, as she mentioned, was a lawyer, is a lawyer, had this great Twitter thread, which I'm going to briefly quote here. Lawyers and doctors enter their professions knowing from the outset just how heavy their burdens are. They hold human rights and life in their hands. Highly impactful professions know that their limits must be more stringent. Or, as all the comic book nerds in the room know, with great power comes great responsibility. This is the basis of professional ethics. Now, historically, licensing in professional organizations, so we're talking, you know, the American Medical Association, the American Institute of Architects, American Society of Mechanical Engineers, bar associations, have arisen from the professions themselves rather than being imposed by the government clumsily from the outside. The professions have actually asked for the protection of government regulation. And the government delegates the licensing requirements to those organizations. And we have certifications in our industry, but I think a lot of us would agree that most of them are useless. There's a lot of rent-seeking around that, like, it's these for-profit organizations that are like, well, you can get our cert, and I'm going to avoid naming them. But professional organization without the consequences of regulation is basically toothless. So before we get the government involved, because that's kind of a one-way trip, we should think about what some of the side effects of a regulation-supported monopoly might be. There's a study in the National Bureau of Economic Research that showed that professional organizations mostly have acted to counter information asymmetry rather than producing monopoly pricing power. So I'm not a doctor. I go to a doctor. That person has been vetted by the boards to meet certain minimum standards of fair dealing, of competence, and of safety. And I can rely on that as a consumer of their services. So in other words, these organizations serve as gatekeepers. Well, that's maybe a little problematic, right? We have enough barriers to entry in our profession as it is. We still have a lot of work to do on that, in fact. So adding new barriers like, well, you must have this degree, or you must have this many years of experience working under another licensed developer, maybe not the direction we want to go. But the advantage of a professional organization is that at least would give us a shared baseline. Right now, we're all trying to figure this out ourselves. And we should hold each other to task. So, okay, what do we do? Waiting for regulation seems kind of like a bad idea. Relying on consent hasn't really worked out. Professional organizations are fraught with gatekeeping risks. Waiting for the industry to fix it isn't working. But we individually are the industry. We can take individual action. So we can talk, what can we do? We can talk about this stuff. There's a conference going on today, Co-ed Ethics in London, which is sponsored by the great folks at Container Solutions. This was driven largely by Ann Curie and their CEO, Jamie Dobson. We can influence the community. There are activist organizations that are springing up over the last few years to push for broader change across many organizations. This is the Tech Workers Coalition. We can also influence our organizations. We see Microsoft employees pushing for change in what customers they want to serve. We've seen successful protests by Googlers motivated by their conscience. And we've seen Amazon employees pushing for change. Now, here's where we kind of get into the what about, right? So because we have this restricted set of common values, it isn't terribly constructive to say, well, the Microsofties are protesting ICE, and maybe I agree with that, and maybe I don't, but let's assume that we do for the moment. But then turn around and say, well, what about their military contracts? Or what about that time 17 years ago when their CEO said Linux was a cancer? These meanie head things about open source, right? But that's not helpful, actually. And while you may think that someone isn't doing enough, at least they're doing something. They're not sitting around ranting about it on Twitter. Okay, an exercise I always love. Raise your hands if you are working for an organization that's hiring. Okay, look around. Wait, keep them up. Look around. This is power. The labor market for our profession gives us enormous power right now. We can push hard for better hiring policies. We can push hard for better diversity and inclusion efforts. We can push hard for our organizations to be better. That being said, we should also cut each other some slack. You don't know much about the circumstances of any other particular person in this room. So while we should be holding, do they have health problems? Do they have family to take care of? What's kind of like their set of circumstances they bring as a human being? So while we should be holding each other to task and encouraging each other to do better, individuals do need to make their own decisions about where they work. And that doesn't make them the enemy, capital letters, unless maybe if they work at Palantir, just saying. All right. What is available to everyone in this room, regardless of our work conditions, and perhaps more effective than anything else that we can do, is direct action at the engineering level. What choices are we making as technologists? So the pipelines that we use to ingest data in many organizations are immutable event stores. This means that once data is written, it's never really erased. This is a diagram about Kafka, I think. And if you're keeping the entire commit history in there, you're going to run into a lot of problems with privacy, right? GDPR hates this. You're like, well, I'm rolling it off over time. It's like, did you remember your backups? Because you still have data there. But with changes at the application level, we can actually still make this work. We could use per-user encryption keys for a stream, right? So we still have encryption at rest, which is great. But we've also made our immutable event infrastructure compatible with the right to be forgotten, right? You delete that per user key and the stream is no longer readable. We need to take responsibility for quality proportional to the risks involved with the software that we're building. Now, certainly this is obvious with directly life-impacting software like self-driving vehicles. But it extends to every piece of software with real-world impact. We need to be part of the chain of safety around these systems. We need to take responsibility for having a deep understanding of how the security of our systems are bootstrapped. And we need to make decisions about that that are aligned with our values. I want to talk about secure boot again. In the case of IoT, this is one of our options. So basically what happens is you provide the factory where your device is being assembled with your public key. And that gets written to a write-only memory. They blow physical fuses on there so it can never be changed. And that means that only your signed bootloader and operating system can be loaded onto the device. It's actually pretty cool. To do that, you need to make sure that your organization has PKI infrastructure in place. To sign that bootloader and operating system, it needs to be part of your CI pipeline. Getting familiar with secret stores like HashiCorp Vault can really help you out with this. But there's a trade-off here. If you have secure boot, that means that your users will find it much more difficult, if not impossible, to modify and repair their firmware. So this is a business decision, but it's also a decision about values, right? And I can't make this one for you. Maybe the answer is different if it's a consumer device versus a business device. But not making the decision, and not as an engineer being part of that decision-making process is abdicating your responsibility. When we deploy IoT devices, we need to make sure we're taking advantage of modern communication. You wouldn't transmit the login form to your web application over plain text, right? Right? Yeah. IoT devices typically have limited compute power, and so folks have often avoided encryption. But we can solve this with modern choices. So TLS 1.3 reduces round trip time, reduces the number of round trips you have to make. Elliptic curve keys can reduce the amount of memory that it takes to do TLS versus RSA keys. Likewise, although you can cram historical or legacy IoT protocols like MQTT into a TLS connection, modern protocols like COAP include mutually authenticated TLS to begin with, so that's part of the protocol. Much easier to do, and less resources. TLS isn't end-user facing in IoT devices, right? There's no green padlock on your IoT device typically telling you that, well, I have the thing. But secure communication isn't about optics. It's about actually being secure. What about our engineering decisions in machine learning? So let's look at one machine learning process called neural net. There's a variant of this called convolutional neural net, which is basically the same thing except a lot more convoluted. If you're not familiar with machine learning, each of these nodes in this diagram is basically just a function. This is actually like, there's a lot of smoke and mirrors on this, right? It's just a function. It takes a vector, so you take an array of data, and you run a filter function over it. And typically the filter takes each filter takes a subset of the array. And then they kind of all feed into each other with weights. And then you iterate on the weights of these inputs, and that allows you to extract features from the training inputs that from that result in interesting classifications, or in other words, decisions. This is the classic iris data set, which I learned recently is about flowers and not about eyes. So each layer builds on the layers after it, but these classifications, the decisions that come out of this, are just kind of weights in a mathematical space. And then when we're done with it, when we're done with our training, they just take the whole weights and we serialize that. We call it a model, and we serialize it, right? So it's like pickle dump. Right? And that we ship that to production. That's basically the result of this thing. And that's what we put our real world data through. Well, so in other words, machine learning models are state, which is kind of funny because we as an industry have spent a lot of the last few years trying to really manage state and get it so everything's stateless, right? Deploy your applications as stateless containers on Kubernetes. Yeah. But machine learning is effectively the ultimate stateful application. You're using software to generate software models, and that's what you ship. Which is going to really get the functional programming crowd in a twist if they ever figure it out. Your entire application is a side effect. So how can we influence those side effects? We're not very good at it. What's really interesting, and the text is kind of small here, this is a paper from Google, right? Yeah. So we desperately need in our industry better tooling to design out unexpected behavior in machine learning. We have undeclared consumers and dependencies, hidden strange loops of feedback. And these represent a source of technical debt. And it's the worst kind of technical debt because it's what John Allspaw and the snafu catchers call shadow debt. It's technical debt that you don't even know that you have. We need to remember that with any machine learning project, that human judgment is required to connect the algorithms to their impact in the real world, our business, our industry, and our community as a whole. The first rule of machine learning should always be, why are we choosing machine learning in the first place? Why are we choosing a method that has these very complex, chaotic feedback mechanisms instead of something that's simple and deterministic? Imagine explaining to your CTO, like, yeah, we chose this web framework and it's really great. When we get unexpected inputs, it just has like totally undefined outputs on hostile input, right? She would be like, well, do you need a vacation? Are you having like, is this just resume-driven development that's causing us to do this? All right. When we do choose machine learning, we should choose our approach with interpretability in mind. Linear or logarithmic regression models are much easier to debug and avoid unexpected feedback loops than models that are self-optimizing. We need to remove unused features, quantify any unexpected behavior. Anything that you see that is unexpected in that model is a potential source of a side channel attack, is a potential source of these adversarial attacks, adversarial inputs, and represent technical debt. We also need to choose machine learning training inputs that reflect the population. This is a fortunate case where we can really easily align engineering ethics with the business in a way that the business understands. Because you say to your project manager, if we pick machine vision training data that reflects real demographics, then our CEO won't have to be on MSNBC explaining to them why our software is racist. Win-win. We can't rely on project managers or business analysts to take the lead on designing our systems ethically because they may simply not understand this stuff. They may not understand the side effects that can be derived from these things. You're the technical professional. They're expecting you to take the lead on this, which is great because the best thing about best practices is that there are so many of them. You don't need to ask permission from your business analysts or project managers on opinions that are purely technical. You can take the lead here. I think formal agile methodologies are actually contributing to this problem. You are not an assembly line worker punching out JIRA tickets. You are a technical professional. You are an engineer. Start acting like it. I want to leave you with this quote from Ann Curie, who's doing that co-ed ethics. We're not a craft anymore. We might feel like artisans with laptops, but what we produce could potentially be in front of a significant chunk of humanity by lunchtime. We're not handcrafting dovetail joints here. What we do have impact. Let's get to work. Thanks, folks.
Powerful stuff, Tim. Thank you. A great place to leave it. So we have lunch here, and we are going to be back in here making open space topics after lunch. So please do come back and see us in a bit. Thanks.